equals 0.045 W V squared, right? So now I'm set up to actually answer the question. The question says, suppose the wind speed doubles to 120 miles per hour, find kinetic energy. So I have that this is the model here, and it wants the kinetic energy, so find E when it says that the wind speed doubles to 120 miles per hour. So that means my weight hasn't changed, so I know the weight still is 1/2 pound, and now the velocity is now 120 miles per hour. Right? So plug that into the model. So E equals 0.045 times the weight, which is 1/2, times 120 squared. Note that this is the answer to this is 324. Now you could enter that into your calculator, 324 joules. A shortcut, if you don't understand this, this is okay, but a pattern you should see is that I've doubled my wind speed, so E equals 0.045 times 1/2 times 2 times 60 squared, right? That's doubling the wind speed, 120. So that's E equals 0.045 times 1/2 times 2 squared is 4 times 60 squared. But the 0.045 times 1/2 times 60 squared, 60 squared, this should look familiar because this is what we had up here. 81 K, our constant, which is we found was 0.045 times 1/2 times 60 squared. This, remember, was just 81. So this part here is just 81. So if 81 times 4 equals E, right, because this was from the original, that was from what we had here before we multiplied both sides by 2. So if E equals 81 times 4, and 81 times 4 is 324. Energy is measured in joules, so there's the answer with a shortcut. Now let's talk about the answers to the problems that we have at the bottom. All right, to solve these, to figure out if they're linear but direct variation or inverse variation, solve for y. So this one is y equals x, just simply y equals x. So this has the form y equals kx, where k is just 1. So this is direct variation. All right. So that one's pretty easy to see, direct variation. This one has no x at all. So since there's no x, it must just be a line. So this is linear. Remember that this is a horizontal line. Okay? Makes a horizontal line, hoivaks. Remember hoivaks. So what about this one? Well, this one, if I solved for y, I would have 2y equals negative x plus 14. Then I would divide by 2, and I have y equals negative 1/2 x plus 7. That is a linear equation. The plus 7 makes it linear and not direct variation. So this is linear. The next one is y equals some constant divided by x. So that's inverse. Inverse variation. The next one, solving for y again. I have y equals negative 2x, right? So that one's direct variation. This one has no y, so this is just a line. So it's linear. The next one, solving for y, I have y equals negative x plus 9, linear. The next one, again, solve for y. Y equals 10 times x, that's direct. This one, we'd have to divide by x on both sides. So we'd have y equals 30 divided by x, so that's inversely proportional. This one, solving for y, I would have y equals 1/4 x, so that's direct. This next one's pretty clear to see that it's inverse. This one, linear. This one will end up being inverse. Y equals negative 18 divided by x, so that's inverse. It's inverse variation. This one's a little bit tricky because I want to solve for y. It's in the denominator. I'm going to take the reciprocal of both sides. So I have that 9 over x equals y over 4. Right? Multiplying both sides by 4, I get y equals 36 over x. So that is inverse variation. Next one's linear. Over here, this is direct because it would be y equals negative 3/2 x, so this is direct. This one's also direct. And this one, again, tricky to see, but to solve for y, I'd multiply both sides by negative 7. So this is also direct. Thanks for watching.